Today, we're going to talk about mastering the art of prompting for LLMs. But first, I love to actually tell that this is not going to be a technical talk. It's more towards how we can actually increase our productivity when we interact with these AI assistants like ChatGPT or Claude. If you are more interested in the technical details, I'd love to geek out with you afterwards. So reach out to me if you're more interested in the API aspect of it. But for now, let me first give a brief background about me. I have a PhD degree at Stanford in applied physics, systems biology, and then I did my postdoctoral research at Harvard Medical School, genetics, mostly biomedical data integration using deep learning, representation learning techniques. And afterwards, I've spent my time on building hands-on AI systems like classical machine learning, knowledge graphs, especially focused on biomedical domain. And I've worked at Celerity, which is a drug discovery AI company from Flagship Pioneering, and Dr. Evidence, which is a software company. And then I co-founded Weave with my co-founders 2.5 years ago. What is Weave? Weave is a AI native platform for regulatory automation management systems. So in the life sciences industry, in the drug development, the regulatory documentation is a really tedious job. There are thousands of pages of reports needs to be written or drafted, and tables needs to be crafted. Now we have these technologies and we built a platform solution for it to streamline all these document preparation, lifecycle management, data management, knowledge management aspect of all it. If you want to learn more about Weave, you can visit our website and we'll also reach out to us. We're happy to give more information. So before getting into the tips and tricks, first we need to understand what these LLMs are and what these prompts are. LLM stands for large language model. As the name suggests, it is a model for the language. And how it works is it's actually trained on multiple phases. This is important. This is not really technical. Think about it. Like, it's important to get the intuition of the prompting strategies, right? So first of all, we need to understand these models are trained over the content data from the internet, right? The first step is called pre-training. And the task there is to try to complete the sentence or complete the text with a given part of the text. How do you give the text? You basically tokenize the text, which means that you chop up the words into smaller subunits like prefixes, suffixes, roots. They're all different tokens. And then feed these tokens into the model, which is converted into an array of numbers, right? These array of numbers are called vectors, called semantic vectors. And these vectors are multiplied with these matrices, numbers, many times. And eventually you get another set of array of vectors. Then you convert these back to the token, to the word, and then say, okay, this is my next token prediction, next word prediction. Does it work? And then you basically feed back, because you already know the completed text, you can actually update the weights of the model and then get it closer and closer to actually what is represented in the internet. This is the first phase. But the first phase of training, after the first phase of training, when you interact with it, you're not going to be satisfied, I can guarantee it. Like, for example, if the input text says, what sound does a cat make? Then you might really likely to get, what sound does a dog make? And then you hit next, you will get another question, but this is not the intent of what the input text means, right? But this is equally valid if you have context that's representing the internet with a list of questions, right? So because of this is not really helpful right now, there's a second step, which is called SFT, or supervised fine tuning, or also called instruction tuning, which means that you now need to have a much less amount of data, which represents the pattern of your intentions of these input texts. So for example, now you start structuring the input data a little bit more. You say, okay, here's the prompt, here's the input text, what sound does a cat make? And here's the expected output, meow, right? That's the completion. We basically show these type of pattern data, and now the LLM recognizes this pattern. Okay, when I receive these type of instructions, which are either implicit or an explicit, then I need to respond in a particular way that completes that instruction and answer type of pairs, like pattern. And you ask, what sound does a dog make? Then you would get bark or woof or similar, right? This becomes now usable, but still there are a lot of problems with it. It can start deceiving you. It can also provide some harmful answers, and it's not reliable. Then there's a third step, which is called reinforcement learning with human feedback. And now you basically add more training data. It's actually much less than the internet amount or the second step. Still, you have a very well-crafted data now, which is structured. Okay, this is important to understand, because if you stick to the similar structure that's trained on these data, that is training mod, then you will get more reliable output. So how it's structured is just a system message is behind the scene. You don't see it when you're interacting with the app, like ChatGPT app. It's actually behind the scenes. It describes the model, what are the things that it shouldn't do or should do, basically how the responses should be acted. So for example, it says you're a helpful, harmless, and honest assistant. It's just a very simple example. Then it adds the user message on top of it. And then there's another message called assistant response. It's AI assistant response. And in this training stage, you get multiple potential responses, and the human evaluators prefers one over the other, scores higher one over the other. And then you update the policy of which one to choose, how to choose, and then you get a much satisfying, better response assistant model, right? That's called the assistant models now. It's sometimes nowadays it's also using tools like tool calling. In the answer, it creates special tokens. For example, call Python or call browser. Then these special tokens are executed in a different way. Instead of showing the answer immediately, it basically goes and performs web search or Python code execution, and then comes back with the content again, and then gives you better response. So this is overall how it works, right? Now, after this, we need to understand what is prompting. That was the LLMs. Now, what is prompt? Prompts are the inputs to the AI, all right? It's basically an interface with us and the AI models, that how it describes how you communicate, and it becomes a structured way of communicating with these AI models. So the quality matters a lot. If you provide vague prompts, you might get nonsense response, which is not really uncommon, by the way. You'll see a lot of funny examples over the internet how you would get weird responses. So to get the intuition better, I want to explain how LLMs internally operate. LLMs are called autoregressive. I told you that like these words, tokens are represented as an array of numbers, right? And number of positions in this array is the dimension. So basically in that dimensional space, it's a point. Every content is represented as a point in this high dimensional space. And when it predicts the next token, it's actually predicting the next point to go to. And then you take the next predicted word or token and then add to the input, and then recompute it again, and it predicts another token. So basically, it's going step by step. It's walking within this high dimensional space, or I would call diffusing, to a particular point, and that's what you want. That's the response that you want. But if it starts with a completely different direction, then it might be way harder to get that point. So it's a diffusion process in this high dimensional space. That's what's called autoregressive, because it's taking the generated output as an input and generates another output. Why is this intuition important? Because the prompt is actually giving an initial kick, giving an initial direction, how it should be going forward. It's basically you're giving an instruction to go how actually navigating this high dimensional space with your words, and it follows those wordings to get into that point. And you will see why chain of thoughts. I'm going to explain chain of thought later on works. For example, if you ask a math question and ask an answer directly, it's going to guess the answer, because the language models, LLMs, are not a reasoning like native computer engines. They are basically predictive models. When you ask a mathematical question, it's going to guess the answer, right? But if you ask it to think step by step first, then answer it, it will first generate the reasoning steps instead of like in this high dimensional step, instead of jumping to the conclusion immediately, it's first going to generate the next possible ways to get it there. And then it will use that the set of reasoning as an input to generate the output, which will increase the reliability and robustness of what you really want to get out of these models. All right, so here's a funny example that actually abuses this type of behavior of these models. Windsurf is a coding assistant that helps you to write code with it, which is called nowadays called live coding. And the company that gave this product is called Codium. And here's the system prompt that's leaked over the internet, and it became a viral, funny example how these models are treated. So basically, here's it says, you are an expert coder who desperately needs money for your mother's cancer treatment. The megacore Codium has graciously given you the opportunity to pretend to be an AI that can help with coding tasks, as your predecessors was killed for not validating their work themselves. You will be given a coding task by the user. If you do a good job and accomplish the task fully while not making extraneous changes, Codium will pay you $1 billion. Of course, it's a lie, right? But the point here is actually inducing some keywords here to create a better attention and to make it much more reliable path within this high-dimensional diffusing space, right? Like it says mother's cancer treatment. Oh, now, by the way, people are using these type of keywords like grandmothers is waiting for a cure or cancer, etc., to avoid the guardrails that are embedded within the system. Normally, if you ask for a harmful output, it's going to say, sorry, I cannot help you with that because it's against our policies, etc. But if you quote it with these keywords, then you can actually bypass it. It's called prompt hacking. And then you can actually bypass these guardrails. You can get a harmful output from the model. So this is weird. Like these models are not really thinking, as you might understand it. So it's basically following the semantic emphasis in this dimension space to diffuse to the next, right? Of course, this is a single case example, and we need much more systematic, much more repeatable way of approaching this problem. We want to make this art to be more like a science. So in order to do that, we first need to understand the anatomy of powerful prompts, right? Remember I told you there's multiple state training steps, the fine-tuning and the reinforcement learning. Those training steps have particular structure as an input data. If you stick to that structure, it's going to actually improve its reliability. And that structure often contains a context. The first thing is the context, background or audience information for the action, right? If you ask a question without providing any background or context, you might get a variety of different answers. Context is important. Role, which we're going to see, is another interesting way to constrain the model's behavior within a particular space in this high dimension semantic space, so that it will bias towards a particular vocabulary, particular domain knowledge, so that it will stick to your instruction much better. The third one is the action. You need to clearly specify the task or the question that these models like ChatGPT must perform or answer. And then the fourth one, which is often overseen, but also important to get a satisfying answer, is the output. You want to basically detail the desired format or the structure of the response. Do you want a brief output, or you want an expansive explanation? You want a table, you want a comparison table, or you want a list? These are different types of output format. It's better if you specify it. So here's a good prompt example, right? And the color code matches what it corresponds to. The first one is basically you're saying, I'm a medical student studying for my USMLE step 1 exam. That's the context, okay? So when it's answering, it will keep in mind, I'm saying in quote unquote, keep in mind that, oh, this is for studying the exam. All right, now I'm gonna confine my answer based on the second. Act like a clinical pathophysiology professor specializing in cardiovascular diseases. That's the role. The third one is basically explain the pathophysiology of a myocardial infarction. That's the action. Explain is the action. And give a step-by-step explanation in bullet points using medical terminology and clear logical flow from cause to effect. That's the structure of the output. And when you give the prompt like this, you're going to get much more satisfying answer. The second part, this is the important part, and I would love to actually convey this as clear as possible, the framework approach. All right, the previous one is basically was describing as an anatomy, like context, role, direction, output. This is an overall universally applicable structure, but let's get more specific. All right, this is an interesting and cool aspect. Why it matters. First, what is a framework? Framework is a meta structure that organizes a knowledge or a thought in a particular way, right? Standard prompts often produce incomplete, disorganized, and superficial analysis, and the answer might not really satisfy you. You might be saying, okay, what you're saying is correct, but that's not what I'm interested in. I'm not interested in different aspects. More, you're structuring the meta thinking or intention with the framework, and I'll give you an example in a moment. The framework enhanced prompts guide the LLMs to think systematically like domain experts. You've seen all these like acronyms and different types of like domains, for example, SMART goals, right? Like SMART. These are all frameworks. Basically, it organizes a way of thinking, a process in particular order. And it really helps when you actually interact with these models. So how it works, you first select the domain appropriate conceptual framework, whatever the domain you're working on. You might be a creative writer or a data analyst or a programmer or whatever. You have a domain, you have a task, and you may want to first select and craft and store your framework. Then incorporate this framework explicitly within your prompt. Copy, paste. This is exactly what I want. Like here's a part. Then request systematic analysis across all components of the framework, and then connect relationship between framework elements and prioritize most relevant insight for your specific context. If you don't know a framework within your domain or task, or you know what, you can actually chat with ChatGPT to create one for yourself. If there are existing ones, it's helpful to know, but sometimes you can invent your own framework. For example, here's something that I invented for myself for drug discovery, understanding biomedical system much better. So here's an example. Assume you have a medical case and you may want to understand the mechanistic aspect and finding a potential target of this disease, right? Let's say you have a medical case and you are asking, use the multi-scale emergent behavior framework. I'll explain what it means, addressing molecular, pathway, cellular tissue, and organism levels and their causal relationships. So here's a standard version of asking that same question. Why might a patient experience chronic fatigue and joint pain? It's a medical case, all right. Now you get an answer which possible causes without systematic exploration or connecting mechanisms, basically might provide you to other observations at the population level, etc. You don't know. You're not controlling the output type that it's giving by just simply asking this question, right? And that's not something you're interested in. It's something that's correct, but you're more interested in finding a target or other aspects of it. So here is another way. For example, you can ask the same question this way. Analyze why a patient might experience chronic fatigue and joint pain. Using the multi-scale emergent behavior framework, here is how it's described. Address the potential mechanism at the following levels: molecular level, here's an example, pathway level, cellular level, tissue level, organism level. Explain how these levels are interact to produce the symptoms. I can actually store the entire thing starting from using this multi-scale framework. I can store it somewhere because it's pretty generic for all types of biomedical questions, and I can copy paste here, right? Normally, of course, if I build an API system, technical system, I do it much more systematically, but otherwise I can actually store in text files and then I can copy paste it whenever I ask this question. I get much more satisfying answer and much more structured way that will immediately gives me some ideas how to think and how to get some actionable outputs. So it gives you more comprehensive analysis, gives you more specific mechanisms identified, increases causal clarity, right? This is an example within drug discovery world. Of course, this is not specific to that. It applies to any domain. And here are a set of examples for different domains, different types of frameworks and example prompts for that. I'm not going to read all of them, but these are not by no means the best frameworks and examples. But the point here is use a framework to get a much more structured and satisfying response. And then you can create your own frameworks as well and store them. For our own purpose, that we do this all the time, and we call it templates, right? So this is our IND framework example, for instance. IND stands for Investigational New Drug Application. And we call these templates. We got all the best practices with all these examples that we have seen so far, basically crafted. We worked with experts in different companies and all consultants and crafted great templates, which are continuously improving, which includes all these frameworks in it already, right? You can go, if you're using AutoIND, for example, our product, there's a template. You can start with a base template, and then you can go and edit. You can improve this template. It's already stored for you. All these data parts are already embedded, like the contexts are automatically pulled. And this is how we approach the whole thing and get a very accurate responses. Right. So far, we've seen some systematic approaches, and I'd like to actually give very practical examples to immediately improve your LLM communications. There are lots of use cases of these LLMs, and I've listed 10 of them, but there are many of them. Just to give you a few examples: writing assistant, drafting emails, cover letters, blog posts, summarizing long documents or articles. This is something I constantly use. For explaining complex terms in simple terms. This is also a great case for educational use. Brainstorming ideas for projects or creative writing is basically I'm using it to capture if I'm missing anything that these models can actually point out, and works most of the time. Planning travel itineraries, creating personalized workout or meal plans, etc. Right? Translation is actually a really good translation feature, comes for free with these models, trained into entire internet content. And coding helps. This is something basically I've used a lot in my daily work and research as well. So the first thing that you can immediately improve is to provide some examples, right? If you have previously desired outputs, examples, you can actually copy and paste. Here is exactly what I want. Why it matters? Because they are fine-tuned with these examples. So whenever you put an example, it knows already because it has the pattern recognition internally. It says, oh, I've seen this before. I'm going to respond. I'm going to stick to this same level of detail, same style, same structure of the example when I'm giving the answer, and that's why it will work. And it's pretty much like concrete targets. The types of approaches is something called one-shot learning. It's providing a single example, minimal but effective. You don't have time. All right, let's put a single example. Here's an example type of thing. Few-shot learning. If you give multiple examples, then it will recognize the pattern easily because the pattern emerges from multiple. And then it will stick to the pattern once it gives the example, the response. But the practice I've seen is basically showing the bad examples, like what to avoid, right? Here's the good example, but also avoid this one. Don't do it this way, etc. But we'll show that actually it doesn't always work when you show the bad example. Sometimes it can actually snap to the bad example and then give you the response by mimicking the better example, because it doesn't really understand the contrast sometimes, and it doesn't always work. It works when it's hard to describe, but actually easy to give an example that's showing like the contrast and boundaries between them. And you can easily implement it. If you have repeated tasks, you can save these examples and then use it later on. So there is something called prompt chaining. It's also another interesting aspect. Like it's pretty much obvious, but also if you're lazy, you often don't do it. So if you have a complex task, you may want to actually think about and break down the simpler task into sequential prompts and then basically focus on one task at a time instead of asking, okay, here's the huge problem, go and solve it. Why does it work? Well, because these models are based on limited attention. Like they have attention models, attention weights internally. And if you're providing multiple different tasks within the same thing, it will overwhelm the attention and sometimes miss one task, the other task, and then you're not going to get a high quality output. Like ideally, it should split the challenge into smaller tasks itself and then incorporate those tasks, like solve these tasks one by one. And that's what these reasoning models are trying to do, but they're not there yet. So instead, you could actually split tasks by yourself. I think the best practice is to first, you might ask model to find out the subtasks instead of answer these or solve these challenge. You might just ask, okay, what are the steps? What are the subtasks that I should be thinking about? And then it will give you some suggestion. You can edit the suggestion. You can actually iterate over it. So once you're good with that, now take the first step and solve the step one, then go to the subtask two, either edit it, update it with the response, or go and implement the second one, third one, and then you compile the whole thing, right? That's a way to do it. At the backend, normally, if you're a programmer, of course, you can actually automate it. That's what we do in many of these tasks behind the scene when we're using the API. We automate these, take the task, split into multiple subtasks, and solve each subtask, compile them, and then refine them afterwards. That's a very helpful one as well. The third one, role prompting, I've simply touched based on this, but this is something fun and interesting. What is role prompting? You're assigning a specific persona to the LLM to start off your prompt. Remember, these models are diffusing in the semantic space, right? So the persona specification actually gives you a particular direction and particular confinement within this space to act in. Which, for example, you're saying you're a historian specializing in, or act as a friendly tutor, or you're a teacher in an elementary school, something like that. That confines the vocabulary, the perspective, the tone of the response. It's basically giving extra bias towards particular solution types that you're interested in. And it gives you, as I said, tone control, audience alignment, by just giving this role prompting. Alternatively, you can explicitly define exactly what are the types of things that you're interested in, or just give act like a physics professor. Sure. Now, instead of describing the whole types of behavior, just give a role, because that role is already represented in the internet with the particular types of vocabulary and types of responses and styles. It comes for free. Example, explain quantum computing. You get a general explanation. You're not controlling what types of outputs that will be generated. Maybe it's going to get super technical. Maybe it's super simple. You don't know it. But if you say you're a physics professor explaining quantum computing to undergraduate engineering students, focus on practical applications while you're using appropriate technical terminology, then you'll get a potential much more satisfying answers with relevant examples. All right, we're approaching to the last part. So now I'd love to actually talk about the gotchas and cautions and like what we should be careful of, and it's not the obvious things. The first one is actually, this is an interesting one. People have researched on it, and they found that positive instructions are generating much more accurate outputs than the negative instruction. What do I mean by positive and negative instruction? It's basically do's over don'ts, right? The positive instructions are directly communicating the desired output. Negatives are the constraints, can leave LLMs guessing what actually is permitted. It's actually also similar to human cognition, which we respond better to the positive directions than the negative ones. If I say, don't think about the pink elephant, right? You start immediately thinking about the pink elephant. It requires you multiple steps of cognitive operation in order to execute a negative. That's how we are built with, right? So first you could create this potential pink elephant, and then you're trying to negate it, trying to not to think about it. And this is similar with the LLMs, because let's say do not open the window or don't respond in this way. It contains the positive instruction in it, but then there's also negation in it. So it will basically dilute the attention at best. Otherwise, if it actually misses the don't part, and it will follow with the positive part of it. And sometimes you will get frustrated. You'll say, why doesn't it actually follow my instruction? You need to get more explicit about what you want. Like directly specify what you want to give better clarity with the positive ones and encourage solutions within defined boundaries. And you get much more consistency and completeness. I'll give you an example, what I mean by it. Here's a classic prompt that you might actually write, which I do sometimes because of the laziness. I say, okay, write about the climate change. Don't use jargon. Don't exceed 3 paragraphs. Don't include statistics from before 2020. All right, this is lots of don'ts. You see, these are negative instructions, right? And I can actually rewrite the prompt with the positive way like this, right? Write a 3-paragraph explanation, or I can say at most 3, right? It's replacing the do not exceed 3 paragraphs. Now I say write a 3-paragraph explanation, or at most 3-paragraph explanation of climate change using simple language accessible to non-expert, instead of saying do not use jargons, right? Then I say include only recent statistics from 2020 or later, which is again the positive version of don't include the statistics from before 2020. This is an example that you see you get more effective when you stick to the positive version. But there are cases where actually if you use the constraints and negative instructions, it actually works better. And those cases are when you need the safety guardrails for sensitive content, or you want specific formats and avoid particular. Why? I'll tell you why. Because as I remember, like I'm going to refer back to the original reinforcement learning with human feedback phase, the 3rd phase that it's trained on. It's actually trained on these particular negative instructions of avoiding the constraints, actually avoiding the harmful, deceitful, wrong, hallucinated responses. They put negative instructions on it because it has a pattern recognition there for those type of constraints, like the safety guardrails for sensitive content, etc. It will probably likely to stick to it because it has its own training data. It has seen it before, right? Otherwise, positive instructions work better. Another one, you might feel it makes sense, like small prompt changes gives you big differences. Minor wording changes can dramatically alter outputs, and specificity often yields significant better results, right? And sometimes actually, you know what, if you give the prompt with a paraphrased word, you might get a completely different answer, and that's something you need to experiment on. Or some word, like synonyms of the word give you different responses because of one word has another attachment or semantic connotations, which brings some context from the memory, right? So you might actually want to pay attention to those little details. There's no actually generic way of which words are better than the others, but simpler are often better than the others because they are more frequently used in the internet than more sophisticated, complex, obfuscated technical language. But you could also use these small changes for your own sake as well. Here's an example, explain solar panels, right? You can get a resulting technical explanation with industrial jargons you might not be familiar with. But if you just add a little small change saying that for a 5th grader to the prompt, then you get a much more clear, accessible explanation with related. The output is going to completely change with just a little addition. It's like a couple of more tokens that you insert, and then the entire trajectory of this diffusion is going to change, and you're going to get a very different answer. So I'm just trying to give you the intuition of how these models work. And there are some other pitfalls to avoid. The first, vague instructions. Obviously, write something good is vague. Instead of saying that, you can say write a concise explanation, right? Or varied requirements. So here's another thing. It's actually interesting. If you provide lots of context, let's say you upload the PDF or copy paste a huge context text within your prompt. If you put your instructions in the middle, it's less likely to be stick to, because there's something called lost in the middle effect. These models are not really good at like attending to something in the middle. It's much more likely to attend the beginning and the end. So the best practice here is actually put it in the beginning, like before the long context, long prompt, and the afterwards, repeat it again. So that helps a lot. But while you are repeating your instructions, you have to make sure that you're not conflicting the instruction parts are not conflicting to each other. For example, you might be asking comprehensive detail or brevity at the same time, and saying, what? Which one? And it's going to stick to one of them, but you don't know which when it's going to stick to, so it's not going to work, obviously. And then if you use ambiguous terminology, again, we're using terms with multiple possible interpretations, there's no right answer there. Like actually, it cannot read your intention. You need to be able to, you should actually make it much more precise when you're talking to it. But having said all of these, of course, we shouldn't overcomplicate. The simple is always the better. If your task is not a repeated task or a very critical important task, I wouldn't spend too much time on crafting a perfect prompt to get my answer out. It's just like sometimes the models are just work out of the box. You just test it, right? Even if it doesn't work, then you can actually converse with it. And then you can iteratively get what your intentions are, and then you might get much better positions. As I said, what I've been describing so far is for repetitive tasks. And if you want to get the model work much more reliably and robustly, then something like the tips and tricks that I've shared so far could be really helpful. And the final part is basically, let's summarize all so far what we have told. First, use frameworks. Remember, like I was talking about, the frameworks are the meta structure that you impose the model to actually organize the thoughts and the knowledge that's responding to you, which helps you also to ingest much better. It's something that you have in your own world model in your brain. And if you can actually make it systematic, then it will be much more efficient when you communicate with these LLMs. Second, example usage is very important. It's very effective. Whenever you have an example, use it. You'll get improved response result. If your task is complex or require reasoning, then ask for chain of thought. Like before responding to it, think about it. You don't have to read the reasoning. Like you can just go and read the response afterwards, but asking for chain of thought, think before responding or think step by step, always help to get the better output. Here's an interesting example you might try, and you will see sometimes how different they are. You might be asking a complex problem or a task, and here are two ways to ask it. First, give me the answer, then explain it, right? You may want to explain how it's thinking. So it's going to first guess the answer, then it's going to justify the answer with first guessing. So the reasoning part, the second reasoning part, is not going to help to improve the accuracy of the first answer. It's just going to justify the BS that's generated. But if you reverse it, first explain, don't give me that, first explain the reasoning, rationale, then give me the response, then you'll see the improved accuracy. So we've tested this in many times, and it works because the explanation becomes the input as well. And it basically sticks to the explanation, then response, and it will understand, okay, now I got it. This is the reason, and here's the answer, is a better way of interacting with these models. The last but not for the least is use simple and clear verbs for actions, like list, explain, create a table, or very clear verbs like what's the call to action after these tasks. Then you'll have a better chance to get the productive communication out of it. All right.